Today we're looking at parallel and perpendicular lines. So what we want to do here is to look at when we can work out the equation of a parallel line to a given line or a perpendicular line. Now the main thing that we're looking at here is looking at the gradient. Okay, so the gradient of the line gives us a lot of information about it. So by the end of the lesson, you should be able to work out the gradient of a line that's parallel or perpendicular to one that's already given to you, and also to work out the equation of a line if we know a point that it's passing through. So to start off, we're looking at parallel lines. So like what I said, when we're looking at lines that are parallel, we know that two parallel lines are going in the same direction. So if they're moving in the same direction, it means that they have the exact same gradient. So how we could write that is m1 equals to m2. So we're using the subscript 1 and 2 to signify the gradient of the two different lines. When we're looking at perpendicular lines, two lines are perpendicular if the product of the gradients is equal to 1. So what that means is if I multiply together m1 and m2, then the answer there is going to be -1. Another way we could write this is by taking the m1 and dividing it across, and I can write the equation as m2 equals to -1 over m1. So that's the relationship between those two gradients. Now we can look at this on a practical level. So if I look at this diagram here, I've got the line OA, and we know that this point there is 2, 1. Now if I know that this is a right angle, what's going to happen is that it's going to move such that we've got a -1 along the horizontal and 2 along the vertical. So that's going to give us a pair of perpendicular sides. So if we were to look at the gradient of these two lines, if I look at the gradient of OA, if we work with rise over run, rise is 1 over 2, so then the gradient of OA is 2. If we look at the point B and I work out rise over run, well, from left to right, it's going down 2 units and across 1 unit. So the gradient there is going to be -2. If I multiply these two values together, half times -2, that's indeed equal to -1. So that's just an example of showing how this works. When we're working with these sorts of questions, if we needed to find the equation of a line, we're going to use the point gradient form a lot more. Okay, so if we were trying to use the gradient intercept form, we will be doing a lot of solving equations. This will actually be a much easier way to find our final answer. Again, if you don't want to use this, you're welcome to use y equals mx plus c, but you'll find that it is a lot more working out than what you would need to do for using the point gradient form. So let's have a look at these questions. So the first one, determine whether the lines are parallel, perpendicular, or neither. So it could be any one of those three. So what we need to do is we need to work out the gradient of each of these lines first. So if we look at the first two equations, y equals to 2x minus 4 and y equals to 2x plus 1, these are already in gradient intercept form, so the gradients are going to be the coefficients of x. So we can see m1 is equal to 2, m2 here is equal to 2 as well. So if we know m1 equals m2, then we know that the lines are parallel, so therefore parallel. If we look at the next example, again, these are already given in gradient intercept form, so we can take the coefficients of x and they're going to be our gradients. So m1 equals to 3, m2 equals to 1/3. Now, when you look at these, you can see clearly they're not equal to each other, so maybe we can check if they're perpendicular. So to check for perpendicular, we're going to multiply them together. So m1 times m2 is 3 times 1/3, which is +1. But if you remember what the rule said, it said that the product had to equal to -1. So this one's going to be neither. therefore neither parallel nor perpendicular. If we come to the next question, now the first one hasn't been given in gradient intercept form, so we're going to need to do some rearranging on that. The second equation has been given in gradient intercept form. So we can write this one out first. So the coefficient of x, which is going to be 1, so we know m2 is going to equal to 1. If we look at the first equation, what we need to do is rearrange it. So what I'm going to do first is, because y is negative, I'm going to move the y to the right, and I can move the 1 to the left. So we could rewrite this as 4x minus 1 equals to 4y. Then we're going to divide everything by 4. So 4 divided by 4 is 1, so we've got x minus a quarter equals to y. And then you can see clearly there what the gradient is. So the gradient, again, is the number in front of the x. That's going to be 1. So m1 is equal to 1. So we've got m1 is 1, m2 is also 1. So then these two lines are parallel. So therefore parallel. In question D, both of them aren't in gradient intercept form. So that's going to be the first thing that we need to do. So for the first equation, what I'm going to do is I'm going to take the 3x and move it to the right, as well as that 4. You can see y is positive, so that's why we want to keep it on the same side. So we can rewrite that as 2y equals to negative 3x plus 4. If you divide everything by 2, you've got minus 3 over 2x plus 2. So that's what the first equation looks like. When we're looking at the second equation, this time can you see y is negative, so I'm actually going to move the y instead. But I'm going to write it with the y on the front, so I can rewrite that as 3y equals to 2x minus 6. So I've moved it over, but I've also swapped the order so that I've got y coming first. Then I'm going to divide by 3, so it's 2/3 x minus 2. So that's our two equations. What we then need to do is work out what the gradients are and see what we can do with those. So the gradient is the coefficient of x. Gradient is coefficient of x. So we've got m1 is negative 3 over 2, and m2 is equal to 2/3. So obviously they're not equal to each other, so we will multiply them together and see what happens there. So m1 times m2 is negative 3 over 2 times 2/3, and that will give you negative 1. So then we know, therefore, the lines are perpendicular. Perpendicular. So those questions were just about identifying parallel and perpendicular. The next examples are for finding the equation of the line. So for the first question, we want a line that's parallel to y equals to 3x minus 2, and it needs to pass through the point 4, negative 1. The first thing we need to do is work out what the gradient of this line is, and then work out the gradient of the line that we require. So if we're looking at this equation, we know that the coefficient of x is the gradient. So m1 is equal to 3. Okay, so that's our first equation, line. For our second line, so m2, if the lines are parallel, then m2 needs to equal to m1. So then we can say m2 equals to 3 as well. So we have our gradient and we've got a point. Okay, so there's your point. So point gradient form, and that was the equation y minus y1 equals mx minus x1. So when we go to substitute the values in, y minus negative 1 equals to 3 bracket x minus 4. So the left-hand side is y plus 1, and if I expand the right-hand side, it's 3x minus 12. So then we'll move the 1 towards the right-hand side by subtracting it. So then y is 3x minus 13. So that would be the equation of the line that we want. For part B, we're going to find the line that is perpendicular to y equals to 2/3 of x plus 7, and it passes through the point 2, 1. So the first thing to note is the gradient. So we've got m1 equals to 2/3. Now, if we want a perpendicular line, then m1 times m2 is equal to -1. Well, that means 2/3 times m2 is -1. We can then solve that by dividing by 2/3. So m2 is going to be -3/2. Once we've got our gradient, we've also got our points. So now we can substitute those into the point gradient formula. Y minus y1 equals mx minus x1. So y minus 1 equals to -3/2 x minus 2. What I'm going to do with this is I'm going to expand the fraction into the bracket. So y minus 1 is -3/2x plus 3, and then I can add the 1 across. So y is -3/2x plus 4. And that's going to be your final answer. So when we're looking at these questions, the main difference, the main thing that we're working with here, is working out a new gradient. Now, when we're looking at these fraction ones, these ones are actually quite interesting here. So when we're looking at the 2/3 and the 3/2, you can see there are points that are quite similar when we're looking at these two values. If we're looking at 2/3 and 3/2, you can see that they're reciprocals of each other. Or in other words, if I flip over 2/3, then I get the 3/2. So sometimes a word that's used to talk about perpendicular is we talk about a negative reciprocal. So to find the gradient of a line that's perpendicular, what we want to do is take whatever the value is, flip it over and throw a minus on it. So the gradient of a line perpendicular is the negative reciprocal of the original gradient. So that's something that might help you when you're working out the gradient of a perpendicular line. So it sort of means that you can go straight from the original gradient to the gradient that we require without having to do all those steps. So that could help you a bit when you're looking at perpendicular lines. Remember, parallel lines are always equal to each other.